Test 2 on trigonometric equations and identities. We had test 1 right in the beginning of this playlist. Here is test 2, which is based on some very good questions which we encountered in last 10 years. So these are first application problems. I'd like you to copy the questions, solve them yourself, and then look into my solution. That is the best way for you to learn while you watch my videos. A1. The intensity of light passing through a polarizing lens can be modeled by the formula A equals to I0 minus I0 over cosecant square theta, where I0 is the intensity of light coming in and I is the intensity of light that emerges out of a lens, and theta is the angle of rotation of lens. So part A is write this expression in terms of sine theta. Part B is, if the angle of rotation of the lens is pi by 3, what fraction of the original light passes through it? Right? So that is the question. So try to do it yourself and then look into my solution. I'm not going to solve this completely, but I'll give you a good hint so that you can get the solution in any way, right? The first part is quite simple, that is to write this expression in terms of sine theta. You could also write it in terms of cos theta. So let me add that part here, right? Sine theta and or cos theta, right? So we'll do that. So that is simple. Let me do that first for you, which is I equals to I0 minus, so cosecant square theta is 1 over sine square theta. So we get I0, instead of cosecant, we get sine square theta in the numerator, right? Now, in case you want to write it in cos theta, then what we'll do here is that we can take common I0, right? So we get here I0 equals to 1 minus sine square theta, right? And what is 1 minus sine square theta? It is cosecant square theta. And so you get I0 cos square theta, right? So this is another form of the same equation, and I think that is much simpler form to write in. So sometimes I've seen this question saying that write this expression in terms of cos theta instead of sine theta. Okay, so that is why I added this portion. Now the part B is, if the angle of rotation of the lens is pi by 3, what fraction of original light passes through? So sometimes I've seen students making a mistake here. They don't really write the fraction, right? So you have to write in the fraction what fraction of original light passes through, correct? Best way to do is very simple. Once you get this formula, plug it in pi by 3 here, right? So we get I equals to I0 cos of pi by 3, right? Pi by 3. And cos square theta really means just square that term, right? This is one and the same thing. Writing cos square theta and writing cos theta whole square is same thing, right? Some students are confused about that also, right? So this is very important for you to understand. Now you can use your special triangles, correct? I draw your attention always to special triangles since I want you to learn that, right? It's kind of important and easy. Now this is 2, this is 1, and this is square root of 3, and that is pi by 3, correct? Now, so cos of pi by 3 is half, right? Cos of pi by 3 is half. And what we can do is we can divide I by I0, I divided by I0, and we get this as half square. Do you see that? Half square. And half square is of course 1 over 4, right? Now read. What fraction of original light passes through? So that is the fraction. Do you see? I is the light passing through, and this is the original light coming in, right? So the fraction which passes through is 1 over 4. So that is the answer, correct? So our solution here is that 1/4 of the light passes through. That is the fraction. 1/4 of light passes through, correct? So that is how you're going to solve it. So all rest of the questions which are there in this video, try to copy them, solve them yourself, and then look into the solution. They're excellent questions. And once you do them, you will be well prepared to get 90 plus. Thank you and all the best.